Importance of analytic geometry. Analytic geometry, also known as coordinate geometry or Cartesian geometry, is a branch of mathematics that deals with the study of geometric shapes and figures using algebraic concepts and techniques. It is a powerful tool for studying geometric problems and for representing geometric concepts and relationships using equations and graphs. There have been many notable figures in the history of analytic geometry, including René Descartes during 1596 to 1650. Descartes is credited with the development of the Cartesian coordinate system, which is used to represent points in space using a set of numerical coordinates. His work laid the foundation for the development of analytic geometry. Next is Isaac Newton. During 1643 to 1727, Newton used analytic geometry to develop his law of motion and to formulate the principles of calculus. His work is considered to be a major milestone in the development of modern physics. Next is Leonhard Euler. During 1707 to 1783, Euler made significant contributions to the field of analytic geometry, including the development of theory of functions of a complex variable and the use of the polar coordinate system to represent points in space. Next is Pierre-Simon Laplace. During 1749 to 1827, Laplace used analytic geometry to study celestial mechanics and to develop his theories of probability and statistics. Last is Carl Friedrich Gauss. During 1777 to 1855, Gauss made numerous contributions to the field of analytic geometry, including the development of theory of elliptic functions and the use of non-Euclidean geometry in the study of curved surfaces. Examples of the use of analytic geometry include the representation of geometric figures using equations, the solution of geometric problems using algebraic techniques, and the use of graphs to visualize relationships between variables. It is a fundamental tool in mathematics and has numerous applications in fields such as physics, engineering, and computer science.
Good day, everyone. Today I will share the importance of history of plane and solid geometry. But first, I'll just give a brief introduction of plane geometry. Plane geometry deals in objects that are flat, surface as triangles, and lines that can be drawn on a flat piece of paper. Let's go to the person who contributed in the plane geometry. Euclid is important because he was the first person to systematize all of the previous observation in geometry into a single coherent system. It was called a Euclidean geometry in his honor, though today it is also known as a plane geometry or the study of shapes on a flat surfaces. It is also include that Euclidean geometry relies an important concept for its developments, and some of them are: first one is point, which is a non-dimensional mark that determines a position in space. Second one is line, is a straight or a one-dimensional figure with no endpoints. It grows indefinitely in both directions. Third one is plane, is a two-dimensional flat surface that grows indefinitely. Fourth one is line segment. It is a finite portion of a line limited by two endpoints. Last one is angle, which calculates the degree of the aperture between two rays lines that grow in only one direction. Furthermore, Euclid has a five postulates in Euclidean geometry. First one is a straight line can be drawn by connecting any 2 points. Second one is a line segment can grow indefinitely in a straight line. Third one is a circle can be drawn by using line segment with length equals the radius of the circle and one endpoints at the center of the circle. Fourth one is all right angles with 90 degrees measurements are congruent. The fifth one is if two lines are intersected by a third line and if the sum of the angles in a inner sides is less than 180 degrees, then the two original lines will intersect each other on the sides if they extended indefinitely. Those mentioned that contributed by Euclid's or is very important because today we use this measurement in plane geometry to have a figure or to create a figure that forms like this. When um not just an engineer uses this kind of format, but all of us, like the toddlers, they create a plane geometry because they draw a triangle, a circle, because it is drawn on a flat surface. Nowadays, by our generation, it is featured in some of the digital platforms. And next one is history of solid geometry and its contribution to the present time. Proponents of solid geometry, we have Archimedes and some of this person who contributed in solid geometry. Archimedes, he was a Greek mathematician, provided principles to thrive in mathematical education and made various contributions. He is the best known for antiquity and the invention of compound pulleys and screw up pump. He contributed so much to solid geometry. Second one is Euclides of Cnidus. He was a Greek astronomer who made an important contribution to the field of geometry. He is thought to have contributed to the theory of proportion forms, the basis for the general account of proportions found in the book 5 of Euclid's Element. Third one is Leonhard Euler. He was one of the giants of 18th century mathematician. He also made contributions to the understanding of planar graphs. He introduced a formula governing the relationship between the numbers of edge, vertices, and faces of a convex polyhedron, which is given such a polyhedron, the alternating sum of vertices, edges, and faces equals a constant. With this formula by Euler's, which he introduced, which is the V minus E plus F equals 2, which is the vertices is equal vertices subtracted to the edge plus the faces equals to 2 because 2 is a constant number in the given formula by Leonhard Euler. Next one is Bartel Landert van der Waarden. He was a Dutch mathematician and historian of mathematics. According to him, there are so many similarities between the studies of Egyptian, Babylonians, Chinese, and also Indians that he believes that these different civilizations' work originated from a common source. This is the given example, which is the book of Polyhydra by Peter R. Cromwell. This polyhedra is exampled by Leonhard Euler in his formula to govern some of the figures, which is the v minus e plus f equals to 2, because 2 is the constant. So, Cromwell in his Polyhydra mentioned the probability that Greek mathematicians who liked traveling a lot needed proof to decide whether Babylonians' method or Egyptians' method are the true ones. So, this book, The Polyhydra, will guide some traveler if they have some um uh like we say the um like some curiosity in their way. So this polyhydra book will govern them or guide them in their way. So the last one is Plato. Plato, when the concern is polyhydra, is most well known as the comments on the five regular polyhydra, which are named after him, although the regular polyhydra are called the Platonic solids. Plato was not the first to recognize them. Polyhyd Pythagoreans already knew three of them for their regularity: the cube, the tetrahedron, they would call it a pyramid, and the last is the dodecahedron. Thetis, a friend of Plato, is known to first discover the regularity of the icosahedron and the octahedron. It must be emphasized that these solids were already known to people, but Pythagoreans and Thetis were the ones discovering their regularity. Solid geometry is the geometry of three-dimensional Euclidean space. It includes the measurement of volumes of various solid figure, or the three-dimensional figures, which is the three-dimensional figures have a depth, weight, and volume. The Pythagoreans dealt with the regular solids, but the pyramids, prism, cones, and cylinder were not studied Platonists until the Platonists. Eudoxus established their measurement, proving the pyramid and cone to have one-third the volume of a prism and cylinder on the same base and of the same height. He was probably also the discoverer of a proof that the volume enclosed by a sphere is proportional to the cube of its radius. Today, our current um, generation, people use solid geometry for many purposes, including engineering and the calculation of perspective. Like, because if we build a building, we should first drawn not just in a plain figure, but we can also draw in a in a 3D figure, like, or we can create in a 3D figure like in some applications that could help those engineering who plan to create it. And that's all. Thank you.
History of probability. Ludwig Boltzmann and Josiah Willard Gibbs. Toward the end of the 19th century, a major success of explanation in terms of probabilities was the statistical mechanics of Ludwig Boltzmann and G. Willard Gibbs, which explain properties of gases such as temperature in terms of the random motions of large number of particles. Ibn Adlan. An important contribution of Ibn Adlan during 1187 to 1268 was on sample size for use of frequency analysis. Dante Alighieri. Dante Alighieri during 1265 to 1321 mentions this game. A commentator of Dante puts further truth into this game. The truth was that with a 3 dice, the lowest number you can get is 3, and ace for every die. Achieving a 4 can be done with 3 die by having a 2 on one die and access on the other 2 dice. Carl Friedrich goes, the power of probabilistic methods in dealing with uncertainty was shown by Gauss' determination of the orbit of series from a few observations. Pierre Simon Laplace. In 1812, Laplace issued his theory analytic these probabilities, in which he consolidated and laid down many fundamental research in probability and statistics, such as the moment of generating function, method of least squares, inductive probability, and hypothesis testing. Next is Girolamo Cardano. Cardano also taught about the sum of 3 dice. At face value, there are the same number of combinations that sum to 9 as those that sum to 10. For example, 621, 593, 522, 441, 432, 333, and for 10, 631, 622, 541, 532, 442, and 433. And last is Al-Kindi. Al-Kindi during 801 to 873 was the first to use statistics to decipher encrypted message, and he wrote a book entitled Manuscript on Deciphering Cryptographic Messages, containing detailed discussion on statistics.